In this lab, we want to apply a force at this thumb position and bend this down such that this face right here is just below this face for a slide latch. And so I'll display the displacement, and so I want to get it below this edge, and I will then animate that displacement, and so we can see how as we push down on this part, it pushes that down. When we're doing this, the idea is that we can parametrically change the width of this slot, we can change the length of these slots, and we can change the position of this feature, this direction or this direction, to see what result it has on the analysis. Start a new inch part file, and first I'll turn on the visibility of the center point so I can keep track of where it's at. And I'm going to do a new sketch on the XY plane, and then I will draw a 2-point rectangle out here in space about like that. And I'll do coincident between the midpoint of the top of this line and the origin. I'll dimension the width of this rectangle at 0.5. and I'll dimension the height of the rectangle as 0.2. I'm then going to offset this rectangle towards the inside a distance of 0.04, and then I will draw a second 2-point rectangle or third 2-point rectangle at this location, and I'll do coincident the midpoint of this line to the midpoint of this line and midpoint here to midpoint there. I'll then dimension the distance from here over to here as 0.25. I'll finish my sketch, and then I'll save the part, and I'm going to name this as slide latch. I'll hide the dimension visibility of the first sketch, and then I'm going to do a new sketch on the top plane, and I'll project geometry this line onto the second sketch. I'll also project geometry this point and this point into my second sketch, and then I will draw a center to center slot with a center point there and a center point here, and I'll do the same thing over here. So I'll draw a center point slot, and you may want to make sure that you get this parallel to the first one or vertical. And I want to make these two slots equal length, so I'll do equal. This one is equal length to this one, and the radius is equal radius between those two. I'm then going to dimension the width of one of these slots, and I'm going to type in slot width, and we can't have any spaces, so I'll put an underscore. Slot width equal 0.03. I'll then dimension the length of one of the slots, and I'll name this slot underscore length equal, and I'll make that 0.25. Now I want to see the names of those variables, so I'm going to come down here and I'll select expression, so I can see that the width of the slot 0.03, the slot length 0.25. I'm then going to draw a rectangle from this point over about like that, and the same thing from here over to about like that. I can make these equal. I might even want to put a line across here so that I can see that those lines should all be collinear. I'll change this to construction line. I'll dimension this distance as 0.05, and I'll dimension this distance as 0.03. I'll then do equal, make this line equal length to this line. So far everything turns dark, it's all fully constrained. I'll then draw a line from the origin, and I want that to be vertical or perpendicular to this line or parallel to one of these lines over here. I'll change that to construction line. I'm then going to do a 2-point rectangle out here in space. I'll do coincident the midpoint of this line to the end of this line. I'll dimension, and I'll set the distance from here to this projected line, and I'm going to name that as thumb position. And I'll set that equal to 0.15. I'll then dimension this distance as 0.1, and I'll dimension this distance as 0.15. I'll finish sketch and save it. I'll then drag my end of part marker up to height sketch number 2, and I'll do extrude this area of sketch number 1. I'm going to flip that direction going towards the back, and I'll go 0.5 inches. I'll drag my end of part marker down, and I'll do extrude again, and this time I'm going to select this area in this slot, this area in this slot, and I'm going to select cut, and I'll select it to go TO this face. And I actually realized that I had that slot in the wrong place, so we'll need to fix that slot. I'm going to turn the visibility of the sketches back on again, and I intended for this point on the slot to be over here. So I'm going to delete this projected point. I may need to delete the constraint first, and then I'll try dragging this over, and I'll also do the same thing over here. So I'll delete that projected point, and I can then drag this over, and I want to project geometry again, and I want to make sure that I get the sketch. So rather than get edge, I'll get the curve or the line, and I projected that up, and I'll do this one over on this side, and I'll do select other, and I want to get that edge, so I projected that up. Then I'll do coincident, and I want this point coincident with that point, and I want this point coincident with that point. So we'll say that I did that on purpose to show how easy it would be to edit the part rather than, say, starting over. I'll turn off the sketch visibility and turn on the sketch 2 visibility, and then I'm going to extrude this area and this area a distance of 0.03125, 0.03125, and then I want to extrude this area then 0.05, and I also want to put a taper on here of 7 degrees. Let's do that, -7 degrees, so that it gets smaller as it goes up towards the top. I can then turn off the visibility of sketch number 2, and I'm going to put a chamfer on this edge and a chamfer on this edge, and the same over here. So I'll select that edge, I'll do chamfer, and for my distance I'm going to do 0.015 on that edge, and on this edge, on this edge, and on this edge. I'm then going to do a sketch on this bottom face, and I will project geometry these edges of this feature, and you may want to do that, project the second sketch rather than select the edges of the feature. And then I'm going to do offset. I'll offset that towards the inside 0.015. I'm then going to do an extrude cut, so I'll go to my extrude, I'll select inside this rectangle, I'm going to put it on cut. For the distance I'll go 0.065, and for the taper angle I'll do -7 degrees. If we check this in a section view, so I'll go to the View tab, I'll select the YZ plane, and I'll do half section. So we see that we have made this cut up into the part. I'll then go to the top view, and I'll do a sketch on this face. I will project geometry, this line and this line. I will draw a line from the midpoint of this line over to the midpoint of this line. I'll change those lines to construction, and then I will do a slot, center to center slot. Actually, let's do a center point slot from the midpoint of this line up to about here and over about like that. I'll then dimension from the center of this arc to the center of this arc as 0.1, and I'll dimension the width of this from here to here as 0.005. I'll then draw an object line from the midpoint of this arc down to the midpoint of this arc. I will do revolve, and I'll select one side or the other of this slot, and I'll select then the axis, the center line, and I'll say OK to that. I'll then do a rectangular pattern, and I will select the last feature that I made, the revolve, and for the direction I'll select this line, and I want 5 copies, a distance of 0.015, and I want those mid-plane. I'll then do fillet, and I'm going to select all of the edges of this feature. Let's change that radius to 0.005, and I'll select these edges and the edges down here, and I'll assign ABS plastic. I'll turn off the visibility of the origin center point. I'm then going to go into the parameters table, and there are several parameters that we named. I'm going to mark this slot width as a key parameter, and I'll also mark it for export and the slot length and the thumb position. Let's then start a stress analysis. I'll create a new study, and I'm going to then put a fixed constraint on the bottom of this face, and I'll apply that and do a fixed constraint on this side, and then I'll do a frictionless constraint on this face and a frictionless constraint on this face. When I push down on this with my thumb, I want this to go down to approximately level with this. So as this is slid into a lock, this feature locks the latch open or closed. So let's measure the distance from here to here, and I see that's 0.031. So I want to do a prescribed offset for that distance. So I'm going to do fixed again, and I'm going to select on this face. If anything here on the whole end move that distance, then our latch is released. So I will select that face, and then I'll use vector components, and on the Y direction I want to go that prescribed distance of minus 0.031. Now I'm concerned about why that's showing as an angle, so I'm going to edit that fixed constraint. Somehow I didn't get my value in here, so I'll put in the 0.031, and I want that to go down, so I need to edit that to negative. Okay, so I've put a prescribed displacement of 0.031. Now I don't want to include these fillets in the analysis, so I will expand the features, and I'm going to go to this revolve feature. I don't want this revolve feature and then the pattern to be part of the study, so I'm going to do exclude from study, and I'm also going to exclude the fillets from the study. I'll then mesh the part, and I think I'd like to have a denser mesh than that. So I'll go to my mesh settings, and let's do 0.025, 0.05. I have some curve elements here and here. Let's do that 15 degrees. And I will update my mesh. I can then turn off the mesh view. I will run this simulation. First I'll check my safety factor, and I see I have a safety factor well below 1, and so we'll need to make some changes to address that. But first let's just check the reaction force at the prescribed displacement. So I'll right click and I'll select reaction force, and it says that it took about 1.3 pounds force to push it down that far. Now our prescribed displacement is up here where we actually push down with our thumb back here. First we need to decide, is that a reasonable amount of force for somebody to use with their thumb on that part? I'm going to copy this study, and then I'll go to assign material, and I'm going to override the plastic material, the ABS plastic, and I'm going to set this as nylon 6.6. Then I'll run my second study with the material as nylon. I'll go to the safety factor, and so we see the safety factor is not as low as it had been. I'll also check the reaction force, and I see that it takes a little bit more force, about 1 3/4 pounds of force to push that down, but with the force being here, not up here where our thumb will be. So we'll actually take more force as we move our thumb back in this direction. Let's copy study 2, and on this one I want to remove the prescribed displacement, and I want to replace that with a force in this location, and I'm going to name that as thumb force equal 3 pounds. Now I'll run this analysis. I'm going to first go to the safety factor, and we see that we're below 1 on the safety factor. But I'll go to the displacement, and I see that I have about 16 thousandths displacement, and we need about 31,000. Let's put this on actual displacement, and if we look at this from the side view, so we need for this area to be down close to level with this area. So let's increase that force. So I will go to the loads and edit that force, and I'm going to change this to 4 pounds, and we'll run our simulation again. At 4 pounds we have about 21 thousandths displacement. Keep in mind that as we push this slide latch, as we push down on here, we're also pushing on it along the Z direction, and this angle right here, or this angle depending on which direction we are going, when it contacts the mating part, may help to push down this latch. We'll leave it at this setting for a few minutes, but if we move this towards the front, we may reduce the amount of force that we need in order to push this down. Let's create a new study. So I'm going to copy this study, and I'm going to edit this study's properties, and instead of doing a single point analysis, we'll tell it to do a parametric dimension analysis. And then I'll click on this parametric table. I may want to track the volume of material that I use in making this part. So I'm going to right click in the parametric table under design constraints name, and I'll say add a design constraint, and I will select the volume and say OK. So I'm going to then just view the value of that volume, the amount of material that we use. Then I'm going to right click again, and I'm going to add a second design constraint, and for this one I want to monitor the safety factor, and I want to then set the lower limit of my safety factor. So I'll click on this cell, and then I'll select lower limit. I want to add another design constraint, and this time I'll select the displacement. Now I notice there's a displacement up here, and then there's a displacement here on just the X, Y, or Z value. I want to know that displacement on the Y value. And then I'm going to set as the lower limit for my displacement 0.031. I may want to fit that in a range so that I don't have too much displacement in, but for now I'll leave this as just I want to displace at least 0.031. I then want to adjust some parameters to see how that affects the model. So I'm going to expand the features of the model. I'll right click and I'll do show parameters, and the parameters that I'm interested in are the slot width, the slot length, the thumb position, and the thumb force. I'll have to go back and mark that as a key variable in order to be able to select that. So we'll say OK to those settings, and let's go back to our parameters, and we'll go down and find that thumb force, and let's mark that as a key variable. And now if I click here again, I should be able to get that thumb force. So I'll do show parameters, and I'll go down. I'm going to size this table over here, and then for the slot width I'm going to put in some discrete values. So I'm going to do 0.03 comma 0.062 comma 0.125. So I use standard tool sizes for end mills that we could use to cut the slot. So don't use just any numbers. Use sizes that would be equivalent to standard tools. Then for our slot length, it could be anything as long as it doesn't go off the end of the part. So I'm going to say do it in a range between 0.025 to 0.04. And let's put that 0.4, and I'll say I can do that in 5 steps. So I'll do 5 steps. And then for the thumb position, I'll put in some discrete values for that as well. And I want to put a shorter position than what I have now, so I need to go in front of the number that I have now, and I'll do 0.1 comma, and then I'll do 0.125 comma, and then my position where it is now 0.015. I then want to create these configurations. I'm going to right click and I can tell it to generate the current configuration, or generate a range of configurations, or generate all configurations. You have to be a little bit careful about choosing this generate all configurations. That is also up here under the simulate. There's also an option here to create a smart set of configurations, exhaustive set of configurations, but I can set my configurations before I run the analysis. So I'm going to go ahead and do that. So I'm going to right click down here and I'll tell it to generate all configurations. Now one thing we have to watch out for is if you do something invalid, for example have this slot go all the way off the end, Inventor will just wait for you to clear that. Ideally it would just continue to do all the other configurations, and then when it finishes tell you some configurations failed, but it doesn't do that. It just stops if it meets any failed configuration. So we'll tell it to generate all configurations. We see the sizes of the features change to match the various configurations. And then I'll go ahead and run the simulation. Now it could take some time to run this simulation, and we see that we have a large deformation for at least one of the configurations, and so we may need to reduce the amount of force that we are pushing down on the thumb latch. So I set the lower limit for the safety factor as 1 and ran the analysis, and it takes 5 to 10 minutes to actually run all of the different configurations. And then we see as we move this slider, so if I make this slot with the smallest size, and so all of these parameters affect each other, and so I have a safety factor that is below 1, but I have got the displacement that I need at least 0.031 in this position. But then if I drag it, make this slot wider, the safety factor has gone up, the displacement has increased more than what I need for it. So I made that slot wider, and so perhaps we could reduce the load on here to get that safety factor to go up higher. Now when we see a lower safety factor, we automatically assume we need to add more material to beef this thing up. But actually on this problem it's actually just the opposite. We need to weaken it so that it is easier for it to push down, so that it doesn't generate as much stress. And then also the stress itself is limited to a very small area around this arc, so it may not be significant as long as it doesn't go all the way across between this arc and this arc over here. But let's examine some of the other settings. So I have the slot length. Let's make that slot length longer, and so my safety factor went down but my displacement went up 3 times what I need, so I can reduce that force. But maybe if I move the thumb position back, so I'll move it back, so my displacement is still much larger than I need if I move this back. So these variables affect each other, and unfortunately Inventor doesn't determine a best case solution. We have to manually decide on that. But everything that I see is most of the positions our displacement is much greater than needed, and so I think the obvious first attempt at achieve a solution might be to reduce the load. So I'll reduce the load pushing down on this and run the analysis again and see what we get. With the load set at 3 pounds and the thumb position moved back far as we have set in the parameters, and then the width on the second width and the length short as we've set it for our parameters, the safety factor is above 1, but the displacement is just a little bit less than what we need for it to be, about 2 thicknesses of a sheet of paper less than what we have specified. Now that may be close enough. If we change the parameters around, we can get greater displacement, but our safety factor goes below 1 again. But I think we can reduce this load a little bit more and then change these parameters and get results. Now I might declare this being okay since it's only about 2 thicknesses of a sheet of paper below what our limit was, that we wanted to have at least 0.031 displacement. So I reduced the load to 2.5 pounds, and we see that in this position we have a displacement of at least 31 thousandths, safety factor of 1. If I move this back, we violated our design intent, and if I move it back up this way, it's okay. If I make the slot much wider, it may still be okay, but I'm going to bring it down. This looks like this might be a less stressful location right there. And then if I drag drag this, make this shorter. I don't quite get enough displacement. If I move it here, I get enough displacement. If I move it here, my safety factor has gone below 1. And if I move it way out here, it's gone way down. So I'm going to put it back in this position. And if I move thumb position over to here, my safety factor is just below 1. I have more displacement than what I need. So I'll move it back this way. And again, I have my displacement. And if I move it back here, so I have two positions here for the thumb position where this the safety factor is okay. I have 38 thousandths displacement there. If I move it here, I have 31 thousandths or 32 thousandths, and my safety factor is a little bit higher. Now, we may need to put some kind of part within this mechanism or a feature so that the operator can't push this down too far, because we've just reduced the load on this in order to pass our safety factor criteria, but they could, of course, without some kind of stop on here, they could continue to put load on here and exceed our load that would make our safety factor too low. Once we get an appropriate design, we can right click and tell it to promote this current configuration to the model. So it's going to physically change the dimensions of the model to match this current configuration. And it'll give you a warning that it's going to do that, and we'll go okay to that, and it'll go through and promote or change our original model to those dimensions.